Okay, in this video, I wanted to walk through some of what we're doing for using the DD program on a Linux distro for our data acquisitions chapter 3. So I'm going to be using a physical drive, so I just have this really old 512 megabit flash drive, and what I'm going to do is I'll connect it to my computer. I have Kali booted up in a VM. What should happen is it should pop up and ask, do I want to connect this to my Windows operating system, which is my host operating system, or do I want to connect it to my Kali box? I've already formatted this drive as FAT32 for what we're doing in this lab. So let's give this a try. I'm going to plug in this Lexar jump drive, and you will want to notice, some characteristics of your drive, like the size, the name, because when you're going through and looking at the different drives available, you want to make sure that you're imaging the correct drive. All right, so let's plug this in and see what happens. Okay, so it popped up as it should, and it says, do you want to connect this Lexar Media jump drive to your host or to your VM? So I want to connect mine to my virtual machine, and that's the only one that I have running, so I'll say OK. And it says the following devices can be connected to this virtual machine using the status bar VM removable devices. So if I wanted, I can go to, let me hit OK. You can see it's here that the device is connected but not mounted, right? If I wanted to add it back in or release it back to the host, I could do that by going into my VMware Workstation menu, go to VM, Removable Devices, select the item, and then I can either disconnect it, and then I can also see that it's connected in my lower status bar down here. So if you look in the bottom right corner, I can hover over and you see the items filled in. See some items that aren't filled in, like this printer. The printer is still connected to my host computer because I don't need it connected to this Linux VM right now. Okay, so what we want to do is, let's see what disk we have available. So I'm logged in as root, so I don't have to type in sudo. So when I do commands, I have administrator permission. What we want to first do is see what disk we have available. So we can do that by going fdisk, let's see, /L, and it should list the different devices that we have. I have a device called devsdc1, and I can see that it is formatted FAT32. I can see this information. There is a drive, a partition on there, SDC. Here's the size. This is the number of sectors. The disk model that it's getting from the device it's picking that information up is called jump drive. I can see over in my preview over here that's something called Dusty Drive, and so that's just what the drive has been named when it was created. Again, I can see size, so I know that this is the right drive and this is the right physical device. All right, so next we want to create a mount point. So we need to make a directory so that we can do that. So mkdir, and so this is going to be SDC1, right? So we want to mount, create a place, we want to make a directory called mount SDC1. So if I go in my file system, I should have an old one where I was working on this before, SDBC1. So if I leave this up as I run this command, you should see a new mount point up here. So I'm going to hit enter, and we see the new mount point SDC1. And so now this is on the drive, on the Linux VM. All right, so now we want to mount the target drive partition. Okay, so we'll go mount T VFAT dev SDC1, and we're going to send it to the place that we just created, and it's called SDC1. All right, so we're getting this. Okay, so now we've added the drive. If you notice, the icon disappeared because now the drive is actually connected to here. All right, so the next thing we want to do is we need to change which directory we're in right now. So we want to get to the mount SDC1 directory, and okay, so now that drive is mounted to this directory. So if I type LSAL, I should be able to see what's on the drive. All right, so I can see that there are some files on the drive. Okay, and now let's create a directory, or a folder called case01 cd desktop. Now let's make a directory. Okay, now that we have that, let's change to, okay, now we're in this directory. All right, now let's open this, and we're going to run. So the command we're going to type in is dd, input file is dev sdc1 pipe split bytes 30 megs, number them, call it image sdc1. Hit enter. We should see this desktop case 1 folder fill up because that's the directory we're currently in. And so hit enter. All right, and then that took just a few seconds, and it tells you the number of records in, number of records out. And now to finish the procedure, you mount. Now we will unmount the drive by going umount dev sdc1. It says the drive is busy. Let's see where it's busy. Let's see if we can close that. I have it open over here. So let me close this. Now let's try this again. Okay, and it unmounted it, and you see the icon pop up again, and it still says it's unmounted. Now I have my case 1, total 17 files. It's got the entire drive in here, and you can see they're numerically ordered from 100 through 116. Okay, and then when the acquisition is finished, do a validation of the suspect drive and the acquired image files. I'm using the validating DD. So let's do a validation. Okay, let's see if that created. Well, okay, we have a hash of our physical drive. Now, let's see if we can get a hash of our image and add it to that same file. So concatenate, so add to that, and we're going to call it image SDC1. Let's see. star. So that should work. And then we want to do MD5 sum. And we want to send it to MD5 underscore SDC1.txt. Okay, and we'll press enter. That was quick. Let's see what it did. And we don't have a match. Wah, 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 wah. So let's try doing dcfldd. Let's see. dcfldd. Do I have that installed? We'll see. It's not looking good. But, dev. Yeah, let me open a new terminal. File, new tab, dcfldd. Doesn't know it. Do you want to install it? Yes, please. All right. Okay, so I installed the dcfldd. So now let's try it again. dcfldd. Okay. Input file equals, it's still dev SDC1. Right, and I'm going to see if I can just not split it. Output file, dusty drive hash equals MD5 hash log equals dusty drive.log. So by default, it looks like it's going into roots documents. Okay, so it gives me some information. And let's see if we can say ls. All right, so I have dusty drive. I didn't split it. So I have that one file. And I have a log file. And so it gives me a hash value. Let's see how that compares to our other hash value. Alright, so start df4 and 7d. Let's see what we have here. df4 and 7d. Okay, so my hash of the physical drive is the same. So let's see if we can get a hash of this image. cd root ls. Alright. So now let's try this. Okay. So now when I do my hashing, I do have the match. So something when I use dd did not go correctly, but when I use the dcfldd, it did go correctly, and I can see that my image matches the hash value that I got from the physical device here and the hash value that I got from the physical device here. So something when I was doing my imaging or my hashing of this set of files, something changed. I'm not sure what changed, but I didn't do the process correctly. So that would have been a problem. I don't think I changed any of the files. I think it just didn't get all of these image segments correctly. I could try one more method. Let's see. Split B 1024 M. Okay. Okay, so I finished doing the imaging. So now I'm going to try to hash, since it only created one image file called dusty_SDC, SDC1 AA. Let's try that. Okay, so now let's check it. And finally, we have a match. So whatever I did with the split images didn't work. But when I used the DD command, I was successful. This is the physical device. This is the image file. And then also when I use the dcfldd, I have a single image file here and the hash value calculated here. They all match. So that's it. So, alrighty.